Welcome to Chem 120 density problems. In today's problem set, we'll be solving the problem to my right here. What is the density in grams per centimeters cubed of a substance weighing 9.2 centigrams, measuring 1.00 centimeters by 3.00 centimeters by 9.97 centimeters? Okay, so what is density? Density is defined as mass over volume. Mass divided by volume. Okay? And in this case, we want that density defined in grams per centimeter cubed. Okay? Grams, little g, right? So, first, what are we given in the problem? Well, we're not given the density, that's what we're trying to solve. Then we're going to say 9.2 centigrams. We have to recognize that centigrams is a weight, okay? But we're not working in centigrams, we want to work in grams, so we have to do a conversion. That conversion for centigrams is 1 gram is 100 centigrams. Now you can use your conversion worksheet to see this relationship for the prefixes. We also have to recognize that that's a mass. So that's our M for this problem. In the density equals mass over volume, this is our mass. But what's our volume, you ask? Great question. So our volume is going to be a combination of centimeters and centimeters. So we need volume. We sometimes think of volume as length times width times height. And in this case, we're going to use those values for those three functions. Volume is a cubic function. So when we see centimeters cubed, we know that's a volume. When we see milliliters, we know that's a volume. And in this problem, we're going to start with 1.00 centimeters times 3.00 centimeters times 9.97 centimeters. Don't get confused by the birds chirping outside. 29.91 centimeters cubed is our volume. So now we're going to plug those two numbers into our density equation. We're going to take the mass of, we got to finish that calculation. Hopefully some of you went ahead and did that. So when you convert from 9.2 centigrams to grams, you end up with 0.92 grams. So 0.092 grams divided by 29.91 centimeters cubed equals 3.075 grams per centimeters cubed. We look at significant figures. Now, for the volume, we have three significant figures in this reading, which, because there's a decimal point, there's 2 zeros, and so they count 1, 2, 3. Same with the second reading, 3.00. Because there's a decimal point, the trailing zeros count. So 3 here. And then here, there are no zeros, so all the numbers count, and there's 3. So 3 significant figures for volume, and then let's look at our mass. Our mass has 2 significant figures. There's a 0, but because it's in front of the number, it can be ignored. And so only 2 significant figures. So we look at these 2 numbers and use this number to round. And we do. And we end up with 3.1 grams per centimeters cubed. And that's how you do the first density problem on the worksheet.